I've been playing around with one of these little USB power banks, and I've discovered what to me is a little design flaw. It's as a result of economy more than anything else. I'm going to plug this in, and the battery is quite low, and it's displaying roughly 5 volts, 4.95 volts, and I'm going to plug a load in, and as the battery voltage, which is here, goes down, you'll see there's a transition point that the the output voltage will suddenly drop. So at the moment the battery voltage is about 3.22. It's kind of risen up and stabilised because I took a wee while before setting this up. Oh, it's actually just cut out at 3.24 volts, and the display has gone slightly berserk. It's flickering and trying to display about 2.7 volts on the display. So I'm going to take the load off and just see what happens. Unplug that and plug it in again, see if I get any sense. Nope, it's gone below the point that can even... Okay, so that was displaying about 2.74, 2.75. I don't know if you can actually see that. It is attempting to display, but it's not coming out very well. However, the interesting thing I discovered is that as soon as it drops round about the 3 volt mark, the switching regulator in this that steps up to 5 volts cuts out. But there's a slight design issue, and I'll show you. Move that to the side. It's based on an FM6316FE chip. It's a very common chip in these things, and if I just strip this back to the very basic circuitry here, to step the voltage up, it's got the chip is driving a transistor. Now this is the lithium battery, the lithium cell, and its negative is going straight out to the USB output at 0 volts, and its positive goes via an inductor and a diode and out to the 5 volts. And the chip, when it detects the voltage, it monitors the voltage of the cell and also senses the output to the USB port for the 5 volts. The chip then fires this transistor repeatedly, and that causes it starts current flowing through the conductor, turns off, and then you get a spike which goes through the Schottky diode, an SP34, which stands for about 3 amps, 40 volts. And the reason they've chosen a Schottky diode is because it's got a very low forward voltage, and it's also very suitable for switching at high frequencies. So the forward voltage can go anywhere from about 0.2 volts to 0.5 volts depending on the current. But the interesting is here that when this chip detects that the battery voltage is going low, it attempts to turn off. So it stops driving this transistor and it stops trying to boost the voltage up to 5 volts. But at that point, if you just ignore everything here, if you've got just a straight resistor connected across, a resistive load connected across the output, then even though the chip's not running, current can still flow through this choke, through this diode, and out and through the load. Which means that even though the battery is down at the 3 volt level, current can still flow. And if you've got a resistive load, or maybe you've been driving a string of LEDs or something like that, because I've got various plans for these power supplies, and it was maybe 2 volt LEDs, like red LEDs, plus the roughly 0.2 volt or 0.3 volt of the Schottky diode, then even though the regulator's turned off, the current is still going to flow, and that voltage of that battery is actually going to go below the point that it should, and the battery could suffer damage. The only way around that I can think of is to use a protected battery where it's got the protection circuit board built in here, so it kills the power when it goes below its sensed voltage threshold. But the snag there is that these little units don't actually have enough room to fit the protected battery in, because the protected battery has a circuit board in the back and it would just make it a wee bit too big to fit in here. So that's kind of a shame really that they don't have that facility to protect against over discharging the battery. I suppose it's not really so much of an issue if you're using it in its intended application of just charging stuff up like phones, and you know, as soon as the voltage drops, the phone will probably stop trying to draw too much current from the power bank. But ultimately, it's not a design flaw, it's just really a design economy. They're just trying to keep the cost of the circuit down and keep the circuit board as simple as possible. But, you know, it was interesting to find out. It will make me wary of using these in some applications. Other than that, you know, they're very useful, but that is just to me a slight a negative aspect.